O'Neill, creator of Animagraphs, and this is how a P51 Mustang works. I've chosen the definitive P51D model, which entered service in late 1943 as a very capable, all-around fighter and long-range bomber escort that helped grant Allied forces air superiority. Let's start with the frame and outer skin. Hundreds of panels are riveted to a supporting structure called the airframe. These parts are mostly made of aluminum for strong yet lightweight construction. Sturdy beams and cross braces support the engine. Hardened steel armor plates in front and behind the cockpit offer some protection to the pilot from enemy gunfire. The fuselage has longerons that extend the length of the frame, and horizontal formers. Ribs and spars make up the wing structure, with smaller stringers for additional support. Aluminum frame components get their yellow coloring from a special protective coating. Exterior parts might have a range of different finishes designed to smooth out bodywork and rivet bumps for a faster and better handling airplane. Landing gear and steering. The main landing gear is controlled by a hydraulic actuator. A separate actuator manages the clamshell doors. A moving lock pin secures the mechanism in place when the gear is down. There's a shock absorber inside the support arm and a brake in each wheel. The pilot can steer the plane while grounded by pressing the left or right rudder pedals, which also engages corresponding wheel brakes. The rear landing gear mechanism is more complex. The assembly is retractable, just like the main landing gear. However, the rear wheel can operate in locked mode, which links its rotation to the airplane's rudder. As the rudder rotates, cables tighten in turn, turning the wheel left or right. Cables pass through a spring-loaded tensioner so they remain taut, but can still move with the rear shock absorber. Engine. The P51D is powered by a Packard V1650 Merlin engine. It has 12 cylinders in a 60-degree V formation and produces 1,400 horsepower with a top speed of 430 plus miles per hour. Air enters through an intake under the nose section and is forced through a large centrifugal or circular-shaped supercharger. Engine cooling is handled with a radiator located just behind the wings, under the fuselage. The low-hanging scoop is separate from the airplane body to capture cleaner air that's further from the turbulence-causing exterior features and propeller air. The placement also allows a longer duct to take advantage of the Meredith effect, where hot air from the radiator's normal function can be used to produce thrust, recovering as much as 90% of the drag caused by the radiator scoop. The radiator exhaust port has an adjustable flap to regulate outflow. A separate engine oil cooler with its own exhaust flap also resides in the scoop. An engine oil tank is mounted to the firewall. A front-mounted tank holds circulating radiator fluid. Exhaust exits through short, angled nozzles. Fuel tanks in each wing hold 92 gallons each, with an additional 85-gallon fuselage tank behind the cockpit. Optional drop tanks can be mounted to the underside of each wing at 110 gallons each, pushing the total fuel capacity to a whopping 489 gallons, with a resulting range of 1,650 miles. A fighter aircraft with the range to reach far into enemy territory proved to be a major game changer in the war effort. Propeller. The propeller is connected directly to the engine through a relatively simple gear set. There is no transmission or gear shift like you'd find in almost any land vehicle. Instead, blade pitch can be controlled. For example, at takeoff, the blades are angled perpendicular to the airplane for a strong forward pull in little to zero existing airflow. While cruising at speed, however, that same pitch would create a barrier, causing drag and slowing forward movement. So the blades are angled more in line with the direction of travel. Armaments. There are 6 Browning .50 caliber machine guns mounted in the wings, with 3 on each side. They're controlled by a stick-mounted trigger which, when activated, fires all guns simultaneously. Ammo capacity is 1,880 rounds, with a fire rate of about 30 rounds per second. With all 6 guns firing together, that's about 30 seconds of total firing time. There's no cockpit indicator for rounds remaining. A camera mounted in each wing can be set to turn on when guns are fired to record the result. A single removable bomb rack can be fitted to the underside of each wing to carry 100, 250, or 500-pound bombs. Alternatively, these racks can carry droppable fuel tanks. 6 rockets can also be loaded, with 3 on each wing, or 10 total rockets when the bomb rack is not in use. Cockpit. These planes were designed for technical war operations and were not expected to be comfortable as a first priority. Some pilots reported having to be lifted out of the cockpit after deep range missions in such cramped quarters. Controls and gauges cover every surface, leaving space only for the pilot's body and bulky flight gear. Starting from the left side of the cockpit, there's a flare gun case and a flare gun mounting tube that extends through the plane to the exterior. Below that, a wing flap control lever sets the position of the main wing flaps. A set of dials controls various trim tabs on the rudder, ailerons, and elevators. For example, if more fuel gets used in one wing tank than the other, the airplane may become unbalanced and pull in unwanted directions. The appropriate trim tab can be adjusted to counter the unwanted attitude, so the pilot doesn't have to fight against the controls to constantly balance the craft. The radiator and oil cooler switches control the previously shown exhaust flap positions for those systems. Also on this panel, a landing light switch for lights that fold out of the main landing gear bay, and a switch for the left side cockpit light. The landing gear lever is down by the pilot's left leg, as well as the left wing fuel tank gauge. The bomb salvo lever mechanically releases bombs as opposed to the electrically activated button on the stick. The fuel-to-air mixture, propeller RPM, and engine throttle controls are grouped together. The propeller RPM lever setting attempts to maintain constant propeller rotational speed, automatically altering things like engine throttle or propeller blade pitch to do so. The propeller and the air around it functions something like an automatic transmission does in a car, and in the same way, a car's engine RPMs aren't always directly related to the actual speed the car may be traveling. So for an airplane, controlling propeller speed is the best way to control airspeed. Moving to the pilot's forward view, we see the flight stick with a bomb release button on top and the gun trigger at the front. Generally speaking, flight stick left or right movement will roll the plane. Stick forward or back movement alters the pitch. The left and right rudder pedals manage yaw. Beyond the stick, we see the fuel shutoff lever and a fuel tank selector dial. The fairing door emergency pull lever releases landing gear in case of a motorized malfunction. Once released, gear can be manually locked by yawing the plane left or right. A hydraulic pressure gauge is situated nearby. A warning light above the emergency lever indicates if landing gear doors are open. Separate warning lights indicate left and right landing gear lock status. The various switches and knobs nearby control armament settings. Bombs can be released altogether or in a train. Guns can be set as single fire, burst, or fully automatic. The amount of rounds per burst can also be set with the corresponding dial. On the left of this panel, there's the engine ignition switch. In the center, the parking brake. The left switch bank has supercharger boost control and other engine-specific settings. On the right, the oxygen blinker moves with the pilot's breathing to very accurately indicate oxygen consumption with each breath. Pilots need specific oxygen indicators due to the dangers of consuming too much or too little oxygen, which can cause confusion and pilot error. A pressure gauge to the right indicates oxygen system pressure. The oxygen regulator controls flow to the pilot. There are left and right positionable lights for illumination. The yellow line across the dashboard separates flight control-related gauges into their own section. From the left, we have the altimeter for altitude, the airspeed indicator, the directional gyro and compass, which are used together to maintain a specific course of travel. The bank and turn indicator shows the plane's current attitude. The artificial horizon indicates ground angle relative to the plane. Outside the white line, there's the clock, a suction gauge to monitor vacuum pressure, since many of these gauges and instruments use vacuum pressure differences to function. The manifold pressure gauge tracks internal engine pressure. The propeller might be turning at the same speed, but requiring lots of engine force, so manifold pressure must be monitored. There's a coolant temperature gauge, a tachometer for engine RPMs, a carburetor air temperature indicator to make sure the engine air intake stays within a reasonable range, and an oil and fuel pressure gauge. Turning to the pilot's right side, we see electrical and radio equipment controls, including an ammeter to monitor electrical current from the plane's generator. There are switches for generator and battery disconnect, left and right gun heaters, and position lights. Red, green, and amber position lights on the underside of the right wingtip can display codes to indicate friendly aircraft approach at night. Late model P51Ds had a tail radar system to warn of aircraft behind the plane. A radio frequency tuner and headphone hook-in sits beneath that. The last couple modules are radio control units and an IFF system used to signal a friendly aircraft to external radar systems. The right wing fuel tank gauge is on the floor by the seat pan. The canopy crank is also on this side, with an emergency release lever. Just behind the pilot's left ear, there's the fuselage fuel tank gauge, various electronic devices including radio and radar modules, and behind that, the oxygen tank storage bay. Coming back to the pilot's view, we see the gun sight. A standard, straight-ahead sight marked with the plus sign and a compensating sight are projected from horizontal lenses onto a thin pane of angled glass. The pilot sets the wingspan dial at the front to correspond to the target's wingspan, measured in feet. A twist grip on the throttle brings the compensating sight's diamond ring into an imaginary circle around the target's wings. This, combined with the center dot over the target's cockpit, automatically calculates bullet range and arc as both planes move through the air at speed. Pilot. During the era of the P-51, regulations for pilot's gear were a bit more open to individual preference, so I've put together a generalized equipment set. The pilot wears a leather helmet with earphones built in, also a set of goggles, and an oxygen mask with a built-in microphone just above the breathing tube. The pilot wears a vest-style yellow life preserver. Parachute rigging straps encircle the pilot's torso and legs, and extend to a parachute back pad that was often packed with first aid items and a one-person life raft. The pilot's parachute is packaged beneath the seat cushion. All of these things are attached to the parachute rigging and follow the pilot in the event of a bailout. The jacket and coveralls are either wool or cotton, paired with warm leather gloves and boots.